Welcome back everyone. In this video, we will be learning how to use an AI model to train to detect fire and smoke. We'll be using YOLO with Ultralytics and RoboFlow for the datasets. So first things first, we'll need to install Ultralytics, which has YOLO models that we need for the AI training. And I'm using Jetson Orin Nano, which is the Jetson Super Orin. It runs pretty well, so we're going to be using that. One thing you need to make sure is to utilize Jetpack, the newest, which I believe it's Jetpack 6.2 already, even though the website says Jetpack 6.1. It'll save you a lot of hassle. I was personally using Jetpack 6.0, which has a lot of installation error. Now, for some reason, if you still want to use your Jetpack 6.0, I have some debugging and troubleshooting documents in my Patreon. Generally, if you just follow this document, you should have no problem in installing Ultralytic with YOLO. Also, the prerequisite is to ensure that you already have a camera feed that feeds into whether Python or other script of your preference. This is so that you can test the main YOLO11 detection, which already has people detections and object detections built in. I described the process of camera imaging capture in my last video. Feel free to check it out. So I'll save some time and just jump right into the RoboFlow. And if you don't know what RoboFlow is, it's an online computer vision application where you can host your module for AI training. You can host your data for people as well to train on specific tasks, for example, fire or smoke or people detection. It's a really robust pipeline where you can just train everything for computer vision online. First thing, we're going to click on Dataset and we're going to download Dataset. We'll be using download Dataset and make sure it is in YOLO11. And we just want to download the zip file. So let's click on that and hit continue. You'll download the file. And we'll just have to make sure that we extract the zip file. Let's go ahead and check inside the file. You'll see a data set. Let's go in there. And one thing you have to do is change the data.yaml. Mine is already set. You'll have a path that's specifically to your data.yaml. And you need to set that. Once that's done, you will have to go back to the root directory, put your YOLO11 and that point, download it from Ultralytics in the same folder, and we're going to run a command to start training the specific data. We're going to type YOLO detect train. We're going to specify the data file where it's located, and we're going to specify the model that we're using, which is YOLO11 and .pt. We can also specify other parameters that I won't go over in details. But there are epochs, the batch size, how many workers you want to use, cache, and device 0, and the image size. These parameters will determine your mean average position, which basically tells you how accurate your model predictions are. And so it's going to be require a little bit of tuning that I'm not really an expert in this. But once you execute the code, it will start training, starting from epoch 1, using some GPU memory. You can see it executing right now. It took me about 6 hours to run the full model that is trained up to about 60% accuracy, 70% accuracy. Now, I was training onboard Jetson Orin using the hardware, so I'm still quite limited by this GPU power. But you can use the other computers to train and deploy the already trained model onto the Jetson Orin. Once you have your trained model, for example, here it's a fire epoch 50 batch point, which I named it. It's still in the YOLO format, and we're going to convert it to ON and X and convert it to tensor RT, which will allow us to run the inference in real time on Jetson Nano. And so here I wrote a quick Python script to execute it. I couldn't find how to execute in a command line, so if you figure it out, let me know. Once you execute the Python script, you should get a .engine extension, and then you can throw it into your script, which I described in my other episode, and we can run it in real time. So let's look at some results here. Since I can't really replicate a lot of fire, I use a tablet to show some fire images. And here we can see about 40%, 50% confidence. There is a little bit of false detection that was detecting my TV reflecting with the light, orange light. So that tells me I need a little bit more training to get the accuracy up. And I also tried to detect smoke using some image here. Was only able to detect one specific one. Still a little bit false detection. So I changed it to epoch, a little bit of the batch size, trained another 6 hours, and deployed again. Here we have a somewhat more reasonable tracking. Now, there's some overlaps in the bounding box. I think it's just the issue the way I plot it. And so I tuned just a little bit on the epoch and the batch size and trained it a little bit more. I must have over-tuned it, even though it's tracking really well, but the confidence you can really see on the bounding box is still around 50%. I'm trying to get more than 70%, and I'm blocking the light behind me because there's still a little bit of false detection. But at this point, I've been training for 2 days on my model, and I really want to deploy it already. Here's a really cool scenario where it was detecting the sky or the cloud as smoke. And if you think about it, it kind of makes sense. Clouds are formed by water droplets, um, even though it's not really vapor, but it's still in the form of kind of a smoke and fog. So I thought that was interesting. So that's going to be the end of this video. I hope you like it and learned something. If you need reference, you can always go back to my other videos where I explain how to integrate the fire detection with the water pump and with other components of the robot. So I hope you like it, and I will see you next time.
"心